All right, this is chapter 1, lesson 2, powers and exponents. So the first thing I'm going to talk about is a product of repeated factors can be expressed as a blank, that is using an exponent and a base. So in that blank, you're going to write power. Okay. So basically all powers and exponents are is it's just repeated multiplication. So if I wrote something like 2 to the 4th power, what I'm saying is I'm taking 2 and I'm multiplying it by itself 4 times. So 2 times 2 times 2 times 2. And that's 2 to the 4th. So the base is the common factor. That's what this is, right? And the exponent tells you how many times the base is used as the factor. So how many times you multiply the base by itself. So powers are actually read usually in a very specific way. So 3 to the 1 over here is read as 3 to the 1st power, and it has one factor of 3. Then I have 3 with a 2. That's 3 to the 2nd power, or 3 squared. That means 3 times 3. 3 with a 3rd, with a 3. 3 to the 3rd power, or 3 cubed. That's 3 times 3 times 3. 3 to the 4th, so 3 to the 4th power. Okay, 3 times 3 times 3 times 3, 4 times. You can keep going and going and going on forever and ever until you get 3 to the n, and that's 3 to the nth power, okay, or 3 to the nth. And it just tells you that you multiply 3 by however many n's you have, okay? So it does give me some examples to go over with you, so we'll go over them. So first thing is this up here. Okay. Make it a little bit bigger for you. A little bit easier to see. So this tells me A times B times B times A times B, right? So I want to use the properties of operations to rewrite and group like bases together. So I figure out how many A's I have. 1, 2. I have 2 A's, right? So I get A squared. There's 2 of them, so I have A squared. Then I figure out how many B's I have. I have 1, 2, 3, and I get B cubed. So my final answer is A squared B cubed, or A squared times B cubed. Okay? The second type of equation I have, or expression I have, is evaluating something. So I'm going to take negative 2/3 to the 4th power. Now what this tells me is I'm taking everything inside the parentheses, okay? So the whole thing, and I'm multiplying it by itself 4 times. So negative 2/3 times negative 2/3 times negative 2/3 times negative 2/3. Now with fraction multiplication, I just multiply straight across. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. And then negative 8 times negative 2 gives me the positive 16. I do the same thing on the bottom. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 gives me 81. So my final answer is 16 over 81. Okay. My last two are dealing with evaluation based off of A equals a certain number and B equals a certain number. So the first one I have is A squared plus B to the 4th. So what I'm going to do is I'm going to take the A they gave me, and I'm going to substitute it in for wherever I see an A in my expression. I'm going to take 5, which they gave me for B, and I'm going to substitute it in for B. So A was 3, so I get 3 squared. B was 5, so I get 5 to the 4th. 3 squared is 3 times 3. 5 to the 4th is 5 times 5 times 5 times 5. When I simplify that, 3 times 3 gives me 9. 5 times 5 is 25. 25 times 5 is 125. 125 times 5 gives me the 625. And then I add them together and I get 634. Okay. I can do the same thing with this problem over here. I'm going to substitute in A and B. A is 3, B is 5. Now it's in parentheses, so 3 minus 5 gives me negative 2, and then negative 2 squared. So that's negative 2 times negative 2, which gives me 4. Remember to follow, please excuse my dear Aunt Sally. Okay, so go ahead, pause the video now, and do the 9 try-it problems at the bottom of the page. When you're done, come back and we'll go over the answers together. All right, so you've paused the video. Now let's go over the try-it problems. Okay. So the first couple of problems over here, A, B, and C, ask you to write each expression using exponents. So my base here, I have 1/2 times 1/2 times 1/2 times 1/2. So my base is going to be 1/2. I'm going to put that in parentheses. So anytime you have a fraction, it's a good idea to put it in parentheses. And there are 1, 2, 3, 4 of them, so it's 1/2 to the 4th power. Okay. B, I have 4 times 4 times 4 times 5 times 5. So I have 1, 2, 3 4s, so that's 4 to the 3rd power. And then I have 2 5s, so that's 5 to the 2nd power. I'm just multiplying these together. It didn't tell me to evaluate this, so I'm going to leave it in the exponential form. Okay. Then I have letter C down here, which is m times m times n times n times m. So I have 1, 2, 3 m's. And 1, 2 n's. So I get m to the 3rd n squared. Okay. You can, m to the 3rd times n squared. You can leave it like this, or you can add a dot in between them, which is the multiplication symbol. Completely up to you. This is usually how you will see it though. Okay. All right, then for D, E, and F, it asks me to evaluate each expression. So that means I have to solve it. Evaluating means solve. So I have 4 to the 4th power, which is the same thing as saying 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. And then 64 times 4 is 256. So again, it's 4 times 4, so that's 16, 64, and then the 256. Okay. E tells me -2 in parentheses to the 6th power. So that's the same thing as saying -2 times -2 times -2 times -2 times -2 times -2. 1, 2, 3, 4, 5, 6. I got 6 of them. So I'm multiplying -2 times -2 is 4. 4 times -2 is -8. -8 times -2 is positive 16. 16 times -2 is -32. And then -32 times -2 is positive 64. Okay. You can always double check. There are 6 negatives, so my answer will be positive because there's an even number of negatives. 2, 2, 2, 2, 2, 2 gives me 64. Okay. Then the last one in this column is 1/5 to the 3rd power. So that means 1/5 times 1/5 times 1/5. So this, I just multiply straight across. 1 times 1 times 1 is 1. 5 times 5 is 25. Times 5 gives me 125. So my final answer is 1/125. For letter G, A school basketball court has an area of 2 to the third power times 3 times 5 squared times 7 square feet. What is the area of a school basketball court? So basically what I want to do is I want to evaluate 2 to the third power and 5 squared and then multiply all my numbers together. So 2 to the third power is really 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And 5 squared is really 5 times 5, or 25. So then I have 8 times 3 times 5 times 7. When I multiply all that together, so I can pull out my calculator, right? 8 times 3 times 25 times 7. I get 4,200. Okay, and it is area and it is square feet. So I have feet with a little 2, square feet. You could also write like that, completely up to you, it's the same thing. Or you could write out square feet, all right? The next one tells me evaluate each expression if C equals -4 and D equals 9. So H tells me C cubed plus D squared. So I'm going to plug in -4 for C and 9 for D. Notice I put the -4 in parentheses because that's what it's, C is -4, right? So that's really important. -4 times -4 is 16. 16 times -4 is -64. So this is -64. 9 squared, 9 times 9 gives me 81, and then I add this together. I have -64, positive 81. So this is like I'm saying I borrowed $64 and then I paid someone $81. So how much money do I have left, right? So I bought something for 64, I had 81. So I'm gonna subtract them. 81 minus 64 will give me 17. So my final answer is 17. 81 is bigger than 64, 81 is positive, so my final answer will also be positive. Okay. The last one I have down here is D cubed minus the quantity C squared minus 2. Okay. So I'm gonna go ahead and substitute in my variables. D is 9, so 9 cubed minus -4 squared minus 2 in parentheses. Again, notice I keep that -4 in parentheses to remind myself that I'm multiplying -4 times -4. That's the base that I'm multiplying it by, okay? Now, according to Please Excuse My Dear Aunt Sally or PEMDAS, I do parentheses first, then I do exponents, okay? So I'm gonna go ahead and do what's inside my parentheses first. -4 squared is -4 times -4, which gives me 16 minus 2. Okay. 16 minus 2 gives me 14. Then I have 9 cubed. 9 cubed is 9 times 9, 81 times 9, which is 729 minus 14. Which gives me a final answer of 715. And that is the end of lesson 2.